Hi, so sections 5.1 and 5.2 were about basically finding areas or probabilities under the curve. 5.3 is exactly the opposite. So what we're going to do is we are going to find the value given the probability or area. So there's really two types of main questions in chapter 5. You can either be asked to find a probability or area. So probability slash area question mark or a value, and they'll give you the probability or area if you have to find the value. And a value can either be an actual value in a data set or it could be a z-score. So first of all, we'll just start with finding the z-scores. So the z-score is, remember, the number of standard deviations a value is away from the mean, and we want to find the z-score that corresponds to a cumulative area of 0.3632. And if you remember the wise words of Beyonce said, to the left, everything you own in the box to the left. So, because we're moving to the left, we are going to find the area. We want to find the z-score where the 0.3632 is to the left. So we want to find this z-score. So what is this z-score? Well, basically we have to use the table in reverse. So if we go back to our normal distribution table, we want to find 0.3632. Now there's a couple tricks you can use here, because if you're trying to find 0.3632, 0.3632 is less than 0.5. So we know this is going to be a negative z-score, because a z-score of 0 has 0.5, or exactly half of the area to the left. So 0.3632 is actually right here. It's negative 0.3. 5. It was in this column. And how did I get that so fast? Well, there's a pattern here. If you notice, the farther we get away from 0, the smaller the area is for the negative side, because there's less and less area to the left. So what a good strategy to use if you're new to this is just to look at the numbers on the left side, find a number that's close to 0.3632, which is like right here, and then move to the right and see if you can find it, and sure enough, it's right there. So that's negative, once again, that's negative 0.35 is our answer, and that's our z-score. So that is finding the area to the left. Negative 0.35. Okay, let's find the area that has 10.75% of a distribution's area to the right. So this time they tell you it's to the right, and we'll change that to a decimal, 0.1075, meaning that this is 0.8925. So if I want to look up 0.8925, that is a positive z-score, because the positive z-score is going to have an area to the left greater than 0.5. And remember that the reason why I did this is because the numbers in the table are always the area to the left. So even though they gave us 10.75% to the right, I need to find the area to the left first. So I want to point that out. So I found the area to the left first, and then I look up 0.8925, because that's 1 minus 0.1075, and that gives me 0.8925, 1.24 it looks like, because 0.8925 is right here. So that's 1.24. So my z-score is 1.24. So basically, we're doing the table in the reverse. And it's very important you pay attention to the question. Are we asking for an area or a probability? Or an area probability, or are we asking for a value? We're doing the reverse now, so now we're asking for values. So let's do a few more. Now these, we want to find the z-score that corresponds to that percentile, decile, or quartile. So for example, for the percentile, that would be, if you remember back to the percentile section, a percentile of the fifth means that there's 5% below that z-score. So we have to find 5%. And 5% is 0.05 as a decimal. So in the body of the chart, I look up 0.05 and I see this one, and I actually see two. I see 0.0505 and I see 0.0495. So there's not an exact value that's 0.05. And what you do in this situation is you just pick the number that's closest. So what's closer to 0.05? 0.0505 or 0.0495? Well, if you think about it, they're actually the same distance away. So what we do is we average the z-scores. So we would normally just pick what's closest. Sometimes you don't find the exact number that's in the table. But in this case, because they're the same distance away, we're just going to pick the, we're just going to average the two. So that's negative 1.645 because that's in between negative 1.64 and negative 1.65. So I'll write this out over here. So basically we found 0.0505. We found 0.0495 in the table. The z-score is negative 1.65. And actually, no, that's negative 1.64. The z-score over here was negative 1.65. So what's exactly in between these? Negative 1.645 is the answer. And this is actually a very popular z-score, 1.645 and negative 1.645. It's because it's exactly 5% on either side. So that's going to come up quite a bit, the 1.645. Okay, quartile. Well, what percent is below the third quartile? Give you a second to think about it as I draw this. Well, the third quartile, remember, is the 75th percentile because 3/4 is 75 cents or 75%. So we want to look up 0.7500. So once again, in the body of the chart, 0.7500, that's going to be a positive z-score. And there isn't one that's closest. There's 0.7486 and there's 0.7517. But which one's closest? Well, 0.7486 is 14 ten-thousandths away, and this is 17 ten-thousandths away from 0.75. So I'm going to pick this guy because that is actually the closer number to 0.75, which is 0.67. And some people are really good at doing this mental math. And if you can't do the mental math that quickly, just subtract. You know, there's no shame in using a calculator and subtracting. Might take you a little longer to do the problem, but that's how you find which one's closer. So once again, I'll write it out. 0.7486, 0.7517. This is closer. And that was the z-score that went with that. Okay, the third decile. Well, third decile divides it into tenths, so that would be 30%. So what z-score goes with 30%? So that's 0.3. And 0.3, we have 0.3015, we have 0.2981. And of those two, it looks like the 0.3015 is closest, which is negative 0.52. So the z-score is negative 0.52. Yeah, and that was 0.3015 and 0.2981. And this guy was the winner. So that was the z-score. All right. So try to do the 57th percentile on your own. Try to look it up and see if you can find the z-score before I write out my normal curve here. So this is 0.57. So we need to look up 0.57. If you need to pause it, give yourself a couple more minutes, you can. Or a few more seconds. So 0.57. .5675 and 0.5714. 0.5714 is closest. That's 0.18. That's because 0.5714, it was between 0.5714 and 0.5675. This one's closest. Okay? And that's how you find the z-score. So basically, now what we're going to do is we're going to move on to actual problems. So we know how to use the table now, or you should after doing several of these examples. And after using the table backwards, we're going to do a few problems. So if we go back, remember the z-score formula is x minus mu over sigma. And you can multiply both sides by sigma. So if you multiply this equation both sides by sigma, you get this. And if you add mu to both sides, you can solve for x. So x equals mu plus z sigma. And that's what we can do right here. So this is a new formula that we can use. And you actually can use the z-score formula every time you do this. But if you just use x equals mu plus z sigma, it's already solved for x. So you don't have to worry about solving for x. So what this formula does is if we know the mean, standard deviation, and the z-score, we can find the data value that we're talking about. So the mean in this problem, it says the speeds of vehicles along a stretch of highway are normally distributed with a mean of 67, standard deviation of 4. Okay, and we want to find the speeds of the vehicles given the following z-scores. And basically we can just use the formula. So x equals mu plus z sigma. So that's 67 plus 1.96 times 4. And this one is going to be 74.84 miles per hour. This is x equals 67 minus 2.33 times 4. So this speed is going to be 57.68 miles per hour. And then this one, the z-score is 0. So before I even start plugging numbers in the formula, you should know what this x value is, because it's equal to what? Should be equal to the mean, because if your z-score is 0, that means you're 0 standard deviations away from the mean, which means you're on the mean. So this is going to be 67 plus 0 times 4, which is just 67 miles per hour. Okay, so now combining the x equals mu plus z sigma, this concept, with using the table in reverse, we can now do a different type of problem. Now we can find problems when we're given areas and given percents, we can find data values. And this is very useful in a variety of cases. One of them is, for example, test scores. There might be a cutoff score. So let's look at an example like that. In this example, it says scores for a civil service exam are normally distributed with a mean of 75 and a standard deviation of 6.5. So right away, I want you to notice they have to give you the mean. They have to give you the standard deviation of 6.5. To be eligible for civil service, you must be in the top 5%. So let's draw a little normal curve here. You don't have to draw a normal curve every time, but I find for many people it's useful. So this is 5%, and it's the top. So I drew the 5% on the right side, which is 0.05. What is the lowest score you can earn and still be eligible for employment? So basically, I want to find out what this z-score is, so that way I can use the z-score, the mean, and the standard deviation to figure out the cutoff score. Well, first off, I need the z-score for the top 5%. Now, the top 5% is to the right, but remember the table gives you the area to the left. So really the number I'm going to look up in the table is 0.95. So let's go to the table and find the z-score that corresponds to 0.95. And 0.95 is right here. 0.9495, which is really close to 0.95, and 0.9505, which is also really close to 0.95. Which one's closer? Well, it's actually a trick question. They're the same distance away, and this is because this has to do with that 95th or 5th percentile. And this is a popular one that comes up, so I'm going to do it again. This and this are the same distance away from 0.95. Well, the z-score for 0.9495 is 1.64. The z-score for 0.9505 is 1.65, so we have to find what's exactly in between the two, and that z-score is 1.645, because 1.64 was the 0.9495 and 1.65 was 0.9505. So x equals mu plus z sigma, and we just use the formula. So our mean was 75. Our standard deviation, or z-score, was 1.645, and our standard deviation was 6.5. And we calculate this to be 85.5 0.6925, so about 85.7. And let's write a sentence about it. So we must score at least 85 points, I'll just round to 0.7, to be eligible for civil service employment. There you go. Pretty simple, huh? Right, so again, I want you to keep in mind, look at the question. The question is, what is the lowest score? It's not the probability of a score or not the area. It is what is the lowest score. In other words, I am finding a value, right? We're finding a value. And that means I'm going to use this formula, not the normal z-score formula we've been talking about. All right, let's do the next example. And I suggest you try to do this part on your own. Try to find the z-score on your own, see if you can get the answer on your own, and then see if your solution matches mine. So hopefully you tried it on your own. And pause the video. And the lowest 1% is right here. Now notice this isn't to the right. This is just the lowest 1%. So what's the z-score for the lowest 1%? Well, that is going to be just 0.01. And 0.01, it looks like it is 0.0102 and 0.00999, or 0.0099. And it looks like 0.0099 is actually closer, just by a little bit, right, to 0.01. So we're going to use this z-score, which is negative 2.33. And our mean from the problem we know is 210. Our standard deviation is 38.6. So x equals mu plus z sigma. The mean is 210. The z-score, standard deviation, we end up getting 120.062. And this is milligrams per deciliter. So the highest cholesterol level in the lowest 1% of men ages 35 to 55. And this kind of sounds wordy, but this is all important information because cholesterol levels are going to vary amongst men and women because they're biologically different, and above ages because as you get older, it's harder to maintain your cholesterol because of metabolic reasons. So it sounds wordy, but just saying men and just saying ages isn't a complete picture. So it's important really to include both of those things. 120.062 milligrams per deciliter. Okay, and that's basically what we're doing. So we're finding the value given the area and the probability. So the first step, find the z-score with that area that they're talking about. Helps to draw a picture. The 1%, make sure you're putting it on the right, on the correct side, whether it's the right side or the left side, depending if it's the upper or the lower. So in this one, I didn't need to subtract from 1, but in this one I did about the civil service exam because that one was actually the upper 5%, right? So again, the first step, find the z-score that associates with the percent, and then use that mean and standard deviation and z-score you just found in this formula right here. Okay. All right, that's section 5.3. Thanks for watching.